Dear students, in the previous lecture, I have shown you how to solve for a given system of equations by using Cramer's rule method under matrix operation to solve for the given variables in the system. However, you can also apply the Cramer's rule method for a 3 by 3 matrix where you just need to form three new matrices by replacing their columns with the vector of constant. The process will be exactly same as you have seen in the previous example of lecture 5.1. That's why I'm not showing it to you with a 3 by 3 example through Cramer's rule, but definitely I will provide you with some exercises so that you can practice a 3 by 3 system of equation by using Cramer's rule and both matrix inversion method. But now I plan to move towards an economic model, and I would like to show both the matrix inversion method and Cramer's rule method to solve for this particular economic application. So this is known as a national income model problem. Okay, so given the model, you need to solve for the variables. Okay, but at first, from the system of equation, you have to identify that which variables are unknown to us and which are for which variables the values are constant or it is given. So under a national income model, there are two equations. Y is equal to C plus I naught and C is equal to C naught plus B Y. So over here, variables like Y, C, these are the variables for which we need to solve the system of equation, because variables like I naught or C naught are basically the vector of constants. That means for these variables the values are fixed. So in that way we can rewrite the first equation as y minus c is equal to I naught to keep the given value, that means the vector of constant, on the right hand side. And for the next equation we can write, as we are keeping the y terms at the first column, so we'll be keeping this by at the first column, and while we are interchanging the side, this plus by becomes a minus by, and this c remains on the same side, so it's a plus c, which is equal to then c naught. So here I naught and c naught are the values which are already given. These are constants and regarded as the vector of constants. So that means y and c are the variables that we need to solve for. Now we need to put this again under the form ax is equal to b, and we have to remember that at first we are getting a matrix full of coefficient values that are associated with these given variables. So over here y is a particular variable. We know that there is a 1 multiplied before y. So for the first one it is 1, for c it is minus 1, and then for the next row it is minus b into y. So here we will get the coefficient as minus b, this is the coefficient over here, and for c it is again a positive 1, and that's how we may form the matrix A. For x, we know that the variables that we need to solve for is y and c, and finally it is equal to the vector of constants, which is I naught and c naught. Okay, now as you can see, this is a 2 by 2 matrix, and we would like to identify the determinant of matrix A. So as you have seen, matrix A is now consisted of 1 minus 1 minus b and 1, right? So over here, if you're trying to identify the determinant, you will do 1 into 1 minus minus 1 into minus b. So we know that minus minus becomes plus, and here 1 is 1. So 1 minus b is the determinant value that becomes here. Now, if you are trying following the matrix inversion method, then you need to identify the cofactor matrix C, right? And these are definitely consisted of minors. So in order to identify the cofactor matrix C, what we will do, we will at first identify the minor of 1, right? This value. So if I'm trying to identify the minor of 1, that particular row and column is out. The minor of 1 is 1. If I'm trying to identify minor of minus 1, then the first row, second column is out. Minor of minus 1 is minus b. If I am trying to identify minor of minus b, then the second row, first column is out, and the value is minus 1. Finally, if we are trying to identify minor of 1, then the second column, second row is out, and the minor of 1 is 1. In that case, the cofactor matrix C would be equal to, remember, it's a 2 by 2 matrix, so plus minus minus plus. Now this is a positive one, and also here a plus sign by the formula, so it remains as 1 minus, next is plus, first is plus, then is minus. Here already a minus from formula, and here is a minus b, so minus minus becomes plus. Then minus plus in the second row. So a negative 1, and here a negative sign makes it a positive 1, and at last 1 is positive and it remains as positive. So this is the cofactor matrix. All the values are in plus form. Now, if you take the transpose of this matrix, what do you get? You are transforming the row into column. So you are taking 1 and b, the first row, and making it a column. Then you're taking the second row 1 1 and making it a column. So this is the cofactor transpose of a cofactor matrix. Finally, under matrix inversion method, in order to identify A inverse, what do you need to do? A inverse is automatically equal to transpose of the cofactor matrix divided by the determinant. So we have got that the determinant is 1 minus b, and the cofactor matrix is 1 1 b 1, right? And at the end, x is equal to A inverse b, so which is equal to, now see, if we can divide it all throughout by 1 over b, but let's make it like that. 1 divided by 1 minus b. Here also 1 divided by 1 minus b. Here it is b divided by 1 minus b. And here it is again 1 divided by 1 minus b. Okay. And you need to multiply it with the vector of constant, which is I naught and C naught. So if you multiply it, then what will be the end result? The end result of x is equal to A inverse b will become, if you multiply the I naught and C naught, this will become I naught divided by 1 minus b plus C naught by 1 minus b. And in the below, it will become, as there is a b there already, so it will become bi naught divided by 1 minus b, okay, and plus it will become the um, bi naught 1 minus b and c naught by 1 minus b, right? So finally, if you add them up, the final answer is I naught plus c naught 1 minus b, and here bi naught plus c naught divided by 1 minus b. So we are done, and what do we get? We get that y is equal to I naught plus c naught divided by 1 minus b, and c is equal to bi naught plus c naught divided by 1 minus b. So these are the answers, and you have done it through the matrix inversion method. Now let's just do it with Cramer's rule method. Still, for the same example, the determinant is same, which is equal to 1 minus b. Just you need to form two new matrices. So you're forming the first one, A1. You will replace the first column, right? So what was your original matrix A? A is equal to 1 minus 1 minus b and 1. Now you will replace this first column with the vector of constant. So the vector of constants are I naught and C naught. And this is minus 1 and 1. So this is your A1. If you identify the determinant of A1, you will get I naught and plus C naught. So this is your A1, and in that case your y is equal to A1 by A, which is equal to I naught plus C naught divided by 1 minus B. So does it match with our earlier answer? Yes, obviously. Y was equal to this, right? Let's form the another matrix A2. Now we will replace the second column. So the first column will remain as it is. Sorry, my bad. Let me rewrite it. It is it was, yes, 1 minus b. So the first column remains as it is. Second column now replaced with the vector of constants. Now let's take the determinant of A2, which is C naught plus Bi naught, or you can write it as Bi naught plus C naught, as there is a plus sign, right? And then to identify C, what you can do is A2 divided by the determinant of A. So we are dividing the determinants of the new matrix divided by the original determinant. So it becomes Bi naught plus C naught divided by A, which is 1 minus B. So here we solve for C as well. So that's how we can solve for the same system of equations by using both the ways or methods, matrix inversion method and Cramer's rule method. Now you can try all these processes for a 3 by 3 matrix. Thank you.